analytic function problem. So find the analytic function. Find the analytic function f of z whose imaginary parts v is equal to e power minus x into x cos y plus y sin y. X cos y plus y sin y. So answer is by Milne Thomson method. So we are going to use by Milne's Thomson method. By Milne Thomson method, you have to write the analytic function f of z is equal to integral phi 1 of z comma 0 into dz plus I into phi 2 of z comma 0 into dz. So let us see what is the phi 1, what is the phi 2. So phi 1 of z comma 0, which is equal to dou v by dou y, at the point z comma 0. Phi 2 of z comma 0 is equal to dou v by dou x at the point z comma 0. So now next we have to find the value of dou v by dou x, dou v by dou y. Okay, so what is v? The given v is equal to e power minus x cos y plus y sin y, x cos y plus y sin y. So e power minus x consider as u, x cos y plus y sin y consider as v. So the product rule is d of uv is equal to u dv plus v du. Okay, so we are going to use this formula. D of uv is equal to u dv plus v du. With respect to x we are going to find, or with respect to y we are going to find. So first with respect to y we are going to find. So with respect to y, if we are going to find, what is the u? U is equal to e power minus x, right? V is equal to x cos y plus y sin y. Okay, so with respect to y we are going to find. So here bx vy. Okay, so uv, so dou v by dou x, dou v by dou y. In this way we have to find. Okay, so first you have to keep this one is as a constant, e power minus x. So e power minus x you have to keep as a constant because u dv. So u is e power minus x, dv. So dv is with respect to y you have to differentiate. With respect to y, if you are differentiating cos y only, you have to differentiate minus x sin y, plus y sin y, again you have to use the product rule. Y you have to keep as a constant, you have to differentiate sin y is cos y, plus sin y you have to keep as a constant, y if you are differentiating, that is 1. In this way you have to differentiate. Okay, so next dou v by v is given, so dou v by dou y, which is equal to e power minus x, you have to keep as a constant as I said earlier. So e power minus x, x cos y if you are differentiating with respect to y, cos y if you are differentiating sin y, minus sin y, so minus x sin y, y sin y, y you have to keep as a constant, sin y if you are differentiating cos y, plus sin y you have to keep as a constant, you have to differentiate y with respect to y means 1. So therefore you have to apply dou v by dou y at the point z comma 0 For x you have to apply z, for y you have to apply 0. So e power minus z sine 0 plus 0 cos 0, because for y you have to apply 0. So sine 0, everything is 0. So that's why answer is 0. Phi 1 of z comma 0 is equal to 0. So this is the answer for first one. So second one is dou v by dou x. So dou v by dou x, which is equal to, so e power minus x you have to keep as a constant. You have to differentiate x cos y. So cos y, x will be 1. So e power minus x into cos y. Next, x cos y plus y sin y, you have to keep as a constant. You have to differentiate e power minus x with respect to x. With respect to x means you will get minus e power minus x. Minus e power minus x. So therefore, dou v by dou x at the point z comma 0. Dou v by dou x at the point z comma 0. So for x, z you have to apply. For y, you have to apply 0. So therefore, e power minus z cos 0 minus e power minus z cos 0 plus 0 sin 0. So what is the cos 0? Cos 0 is 1. So phi 2 of z comma 0 is equal to e power minus z. Cos 0 1. Cos 0 1. Sin 0 0. So therefore e power minus z e power minus z. This can be written as phi 2 of z comma 0, which is equal to e power minus z minus z e power minus z, or else you can write as 1 minus z into e power minus z. Now we are going to apply in the formula. So what is the formula? Formula is f of z, analytic function, f of z is equal to phi 1 of integral phi 1 of z comma 0 into dz plus I into integral phi 2 of z comma 0 into dz. So which is equal to, what is phi 1 of z comma 0? 0 plus I into integral e power minus z minus z e power minus z, right? E power minus z minus z e power minus z into dz. This is a phi 2 of z comma 0, which is equal to I into integral e power minus z into dz minus I into integral z into e power minus z into dz. So therefore, if you apply here, I into e power minus z can be written as e power minus z minus 1 minus I into, this can be solved using the Bernoulli's formula. So what is the Bernoulli's formula? Bernoulli's formula is integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3. U is equal to z, v is equal to e power minus z. So therefore u dash is equal to 1, v1 is equal to minus e power minus z, v2 is equal to e power minus z, u double dash is equal to 0. So therefore minus I into u v1 minus z into e power minus z, minus z into e power minus z. Okay, so next minus u dash 1 v2 e power minus z. This is the integration of z e power minus z, which is equal to minus I, which is equal to minus I e power minus z plus I z e power minus z plus I e power minus z. So first and last cancel. So f of z is equal to I z e power minus z, I z e power minus z plus some constant. Always whenever you do the integration, you have to add constant term. Okay, so this is f of z is equal to I z e power minus z plus constant.